to the next point. We should ensure whatever we see is clear.
That means work is being done. We can see that it is in opposite direction.
Good day, my students. You are welcome to another edition of Ministry of Education, Kaduna State Radio TV e-learning program. Today in our chemistry class, we are taking hydrogen. I remain Ibrahim Omar. You will believe with me that hydrogen is a very important element in the periodic table, because I remember when you are asked to cram the first 20 elements, the first element that comes to your mind is hydrogen. Now, hydrogen is broken down into introduction, occurrence, isotopes, position in the periodic table, laboratory preparation, industrial preparation, physical properties, chemical properties, and of course, uses of hydrogen. Now, hydrogen, how is it discovered? Hydrogen was discovered way back to 1766 by a scientist called Henry Cavendish. He was the first to discover hydrogen and identify some of its properties, but he doesn't name it and he doesn't discuss it extensively on it. It was later that another scientist by name Antonin Lavoisier that named it hydrogen. And the name hydrogen is water former. This is because hydrogen reacts vigorously with air, that is oxygen, in order to produce water or steam. And it is flammable. The meaning of flammable is the fact that it can react with oxygen, that it undergoes combustion reaction. Having said that, we go to occurrence. How does hydrogen occur? Remember, hydrogen does not occur naturally as an atom, but even if it exists very scanty, it exists as a diatomic molecule. But it exists in the atmosphere chemically combined with other elements, such as in water. We all know that water consists of H2O, that is 2 atoms of hydrogen and 1 atom of oxygen. It is present in all acids and it is present in even alkali. So hydrogen is a very important element. Also, hydrogen is a component of organic chemistry, especially in hydrocarbon. The name hydrocarbon is from a compound of hydrogen and carbon, which is the major component of natural gases, such as kerosene, gasoline, which we call petrol, natural gas, and so on. It is also a constituent of organic compounds such as hydrogen, protein, fat, and oil. So hydrogen is almost everywhere. It is a very, very important element. Having said that, we'll go to isotopes. Remember, we define isotopes as the existence of elements with the same atomic number but different mass numbers. So hydrogen also exists with different mass numbers. It has 3 major isotopes. The first one is called hydrogen. Hydrogen has the atomic number of 1 and the mass number of 1. It is called protium. That is because it consists of only 1 proton without neutron. 2, we have the heavy hydrogen. The heavy hydrogen is called deuterium. That is because it has an atomic number of 1 and the mass number of 2. That is 1 electron, 1 proton, and 1 neutron. Then finally, we have what you call tritium. Tritium is a hydrogen with atomic number 1 and mass number 3. That is 1 electron, 1 proton, but 2 neutrons. It is important to note that hydrogen or protium is the most reactive among all the 3 isotopes. Deuterium is also reactive. It forms the compound that hydrogen made, but it is called heavy compound. But tritium is radioactive. That is from the mass number to atomic number ratio. Position in the periodic table. Now, hydrogen is very unique and it has a special position in the periodic table. In fact, it is the only element in the periodic table that has characteristics of two different groups. So it has only one electron in its ground state. So what happens? All the elements that are in one group, one electron, they are called alkali metals, that are metals of group 1. So like the alkali metals, hydrogen has the following properties. 1, it has one electron in its outermost shell. 2, it is fairly electropositive. 3, it is liberated at the cathode during electrolysis of aqueous acidic solution. So this reason make it look like the elements in group 1. But remember, all the elements in group 1 are metals and hydrogen is not a metal. And then hydrogen is diatomic. That makes it not look exactly like the elements in group 1. So where should we place it in that case? Then we place it in group 7, halogens. So like halogens, hydrogen has one electron short of noble gas configuration. It also exists as a diatomic molecule. And then it forms covalent bonds with non-metals. These are some of the properties that looks like the halogen. But remember, it also have another property of alkali metal. So due to these properties that hydrogen has, it is therefore sometimes placed in a central position in the periodic table because it cannot perfectly fit group 1 and it doesn't perfectly fit group 7. So that is to show you how unique hydrogen is. We move to how do we prepare hydrogen in the laboratory. So hydrogen, we have different methods of preparing hydrogen, but there are 3 methods that are generally adopted in the laboratory. The first one is the action of zinc on dilute acids. 2, we have the action of sodium on cold water. And then 3, we have the action of iron on steam. Let's take the first one, action of zinc on dilute acids. Now, based on action of zinc on dilute acid, hydrogen is prepared by the action of zinc on dilute acid. That is either tetraazosulfate 6 acid or it can be hydrochloric acid. As the setup below, the acid is introduced into the round bottom flask where the zinc is placed. So after the reaction, the hydrogen follows out and moves into what? Into where it is collected. Now, it is important to take note of this fact that whenever you are drawing this setup, then you should put stoppard on the point of the acid because it is acid that is being produced, and now this acid or at least gases should be contained in their container. So that is the reaction. The reaction is zinc plus tetraazosulfate 6 acid to give you zinc tetraazosulfate 6 and hydrogen gas. Now the hydrogen produced by this process is called a wet hydrogen because it contains water in it. So how do we dry it? To dry the acid, we pass it, to dry the gas that is being produced, we pass it through concentrated tetraazosulfate 6 acid or fused calcium chloride. And then when it is collected by upward displacement of air, the gas is said to be dry hydrogen gas. Now the second method is the action of sodium on cold water. Now it is important to take note that sodium is very, very reactive and the reaction is vigorous. So this is not always recommended in the laboratory because you have to take the reaction meticulously. But what is the reaction? Sodium can react with water in liquid form to produce alkali, which is sodium hydroxide, and hydrogen gas. And the hydrogen gas is also collected by upward delivery. 3, action of iron on steam. Red hot iron displaces hydrogen from steam as follows. That is 3 moles of iron react with 4 moles of water, that is gaseous water, to give you iron 3, oxygen 4, with 4 atoms or 4 molecules of hydrogen gas. Now this reaction is reversible and then it proceeds under some certain conditions. Now having said that, we go into chemical properties or we go into industrial preparation of hydrogen. This hydrogen we discuss are prepared in the laboratory. So how do we prepare it in industries when we need it in large scale? We have 3 methods of that preparation. The first one is preparation of hydrogen from coke, which is called burst process. We also have the preparation from natural gases such as methane. And finally, it can be prepared on large scale in industry by electrolysis. Now, batch process. When steam is passed over red hot coke, water gas is formed. We all know the reaction that when carbon reacts with when it reacts with water, it produces carbon 2 oxide and hydrogen gas. That is called water gas. Now this water gas reacts with further steam to give you more hydrogen gas, and we use some catalysts sometimes, such as iron 3 oxide or chromate 3 oxide. Now the reaction is as follows. Carbon can react with water to give you water gas, which is carbon 2 oxide and hydrogen gas. Now if this water gas is passed through more steam, then we can have additional hydrogen gas. 2 molecules of hydrogen gas is being produced. So now the carbon 4 oxide is always removed because it is now a byproduct. It can be removed by dissolving it in water under a high pressure of like 30 atmosphere. So the carbon 4 oxide can be removed, which is being produced as a byproduct. The second method, which is from methane, also follows the same format, but in this case, it is methane that is passed over steam in the presence of nickel catalyst at a very high temperature of at least 800 degrees Celsius. Now the reaction is as follows. Methane, CH4, reacts with water in gaseous form to give you 1 mole of carbon 2 oxide and 3 moles of hydrogen gas. Now this reaction can be passed over more steam to produce more hydrogen gas. That is, this carbon 2 oxide that is produced plus 3 moles of hydrogen can react with water again to give you carbon 4 oxide and 4 molecules of hydrogen gas. And now this hydrogen gas can be collected and used in large scale in the industries. And finally, we said by electrolysis. And this is the third method of preparation of hydrogen gas. Now, how do we get it? We get it by electrolysis of brine. When we say brine, we mean dilute sodium chloride. Now, sodium chloride solution undergoes electrolysis in the laboratory, and hydrogen is being deposited. Hydrogen gas will be deposited at the anode. And then at the cathode, we obtain hydrogen gas. Having said that, we go into physical properties of hydrogen. Now, what are the physical properties of hydrogen? Number 1, you should know that hydrogen is a gas, and hydrogen exists as diatomic molecule. So 1, hydrogen is colorless and odorless gas. That means it doesn't have color and it doesn't have odor. It exists just like air. 2, it is neutral to litmus paper. That means when you wet your litmus paper and then you introduce it to hydrogen gas, it will neither change blue nor red. It will remain the same. A blue litmus paper remains blue, a red litmus paper remains red. 3, it has low boiling point of minus 253 degrees Celsius. That's a very, very low boiling point. 4, it is relatively insoluble in water. That means only 2 cm3 of hydrogen gas dissolves in 100 cm3 of water. That means it's just relatively insoluble. That means it does not dissolve in water. Finally, it is the lightest known substances. That is because it has a mass of 1. So a mass of 1 is negligible. So the mass is very, very light. All the substances, all the elements we have are heavier than hydrogen. Hydrogen is the lightest among them. We go to chemical properties of hydrogen. Now, hydrogen undergoes a lot of reactions. We discuss combination reaction first. Now, when we say combination reaction, we mean reacting with other elements or other substances. So now, hydrogen generally reacts with both metals and non-metals to produce hydride and other substances. I'll start by giving you examples with reaction of hydrogen with metals. we said it reacts with active metals that are above hydrogen in the activity series. Remember, we all discussed the activity series, in which above hydrogen we have metals like sodium, we have metals like potassium, we have metals like aluminium, magnesium, calcium, and so on. So hydrogen can react with all these metals to produce what we call metallic halide or metallic hydride. A good example is 2 atoms of sodium reacting with 1 atom on 1 molecule of hydrogen gas to produce sodium halide. That is sodium hydride, that is 2NaH. 2. Reaction with oxygen or other non-metals. Generally, hydrogen reacts with non-metals. So with oxygen, hydrogen burns with a pale blue flame to form steam. An example is given. Remember, this is even the reaction that is used to distinguish hydrogen from other substances. The flame that is produced is blue and it is very pale. Now the reaction is 2 molecules of hydrogen gas reacting with 1 molecule of oxygen to produce 2 molecules of water in steam form, that is in gaseous form. Another reaction is that it reacts with halogens. Reaction with halogens, that are the metal or the element in group 7. It forms halide. The reaction is catalyzed by light, so it is called photocatalytic reaction or photolysis. Example is the reaction between hydrogen and chlorine. 1 molecule of hydrogen gas reacts with 1 molecule of chlorine gas in the presence of light to produce hydrochloric acid, that is 2 molecules of hydrochloric acid. The second form of reaction is it reacts as a reducing agent. We said hydrogen reduces the oxide of metals such as zinc, copper, lead, iron to form respective metals, while it is oxidized to form water. An example is given. Iron 3 oxide reacts with 3 atoms of hydrogen to give you iron solid and then 3 moles of water. This is acting as a reducing agent. So how do we identify hydrogen in the laboratory? This brings us to what we call test for hydrogen. So in the laboratory, we test for hydrogen as follows. Insert a lighted splinter into a test tube containing an unknown gas. If the gas is hydrogen, it burns with a pop sound. Generally, we said hydrogen gives a pop sound when it is lighted with a splinter. Why? That is because the hydrogen explosively reacts with the oxygen that is present in air the moment you open the jar or the container in which the hydrogen gas is there. So that reaction will give you a pop sound due to the vigorosity of the reaction. Finally, we go to uses of hydrogen. Now, what are the uses of hydrogen? Because we said hydrogen is very important. Now, under uses of hydrogen, it is important to note that the first use of hydrogen is that hydrogen reacts with nitrogen to form what we call ammonia. And this ammonia is a source of raw materials for production of fertilizers and some other important chemicals in the laboratory. Another reaction includes that hydrogen is used in the manufacture of ammonia, hydrochloric acid, methanol, to mention but a few. It is also used in filling balloons because of its low density. Remember, I told you that hydrogen is the lightest non-substances, so we can use it to fill balloons so that the balloon will not be heavy. Next one, it is used in hydrogenation of fats to form margarine and also in production of soap. Now, the word hydrogenation simply means reaction of hydrogen to other substances. So now when you have fats reacting with hydrogen, margarine is formed. Oil can also react with hydrogen to form the substance we use in production of soap in the chemical industries. It's also a constituent of fuel gases. We talk about producer gas and water gas, and it all contains hydrogen in this. So now hydrogen is also a constituent of fuel gases. It is used in production of heat in the industry. 5, it is used in oxyhydrogen flame, which give a high temperatures for welding. What do we mean by that? When hydrogen is mixed with pure oxygen, it burns to a very, very high temperature. And this temperature is up to 4,000 degrees Celsius, which can be used to weld the welding of aluminum and some other nickel or other metals can be used using that process. And finally, we said it is used in production of synthetic petrol. When we say synthetic petrol, we are referring to petrol that is being produced in the laboratory, because petrol is a compound of hydrogen and carbon. Having said that, we come to the end of the lesson. But before the end of the lesson, I'll have to summarize the major points that we discuss. First, we talk about hydrogen, and we say hydrogen is discovered, or it was discovered by a scientist called Henry Cavendish. And this scientist couldn't name it, but it was another scientist, that is Antonin Lavoisier, that named it hydrogen, meaning water former. We discussed the occurrence of hydrogen, and we agree that hydrogen do not occur as a free element, but it occurs in combination, such as in petroleum, in hydrocarbons, and in other substances like acid, water, and even alkalis. Under isotopes, we discussed that hydrogen has three major isotopes, which is the protium, the deuterium, and the tritium, with mass number 1, 2, 3, respectively. Position in the electrochemical series, we agree that it can be placed under group 1 due to some properties, such as the fact that it has only 1 electron, and it can be placed under group 7 because it is diatomic in nature. We prepare it in the laboratory by the action of zinc on cold water, and so on and so forth. In the industry, we can prepare it using Bosch process and some other process like electrolysis, and we can also produce it from methane, which is natural gas. Under the physical properties of hydrogen, we agree that hydrogen is a colorless and an odorless gas. And we also agree that hydrogen is the lightest known substance, which is neutral to litmus paper. We talk about its chemical properties, where we agree that hydrogen reacts in combination with both metals, non-metals, and halogens. And it also reacts as a reducing agent. We discussed the uses of hydrogen, in which we said it can be used in welding, it can be used in production of chemicals such as ammonia, and so on and so forth. Having said that, we come to the end of the lesson, but I'll give you assignments to solve at home so that you test your understanding. Number 1, A. Name all the isotopes of hydrogen. 1B. Discuss with reasons the position of hydrogen on the periodic table. Question 2. State 2 physical properties and 2 chemical properties of hydrogen. Question 3. With the aid of chemical equations, discuss 2 methods of preparing hydrogen in the laboratory. And finally, list any 3 uses of hydrogen. The questions again. 1A. Name all the isotopes of hydrogen. B. Discuss with reasons the position of hydrogen on the periodic table. Question 2. State 2 physical properties and 2 chemical properties of hydrogen. Question 3. With the aid of chemical equations, discuss 2 methods of preparing hydrogen in the laboratory. And then question 4 says, list any 3 uses of hydrogen gas. Reference materials. You can consult textbooks and even the internet, but the most important ones I will encourage you to consult are: 1. New School Chemistry by Ababio. 2. Understanding Chemistry by Godwin O. Ojokuku. 3. Senior Secondary Chemistry by S.D. Baja et al. So you can also consult other chemistry textbooks, and you can even consult internet for further research. The references are New School Chemistry, Understanding Chemistry by Godwin Ojokuku, and of course, Senior Secondary Chemistry by S.T. Baja. When you solve your questions, and then you have to submit it to us, or maybe you want further questions you want to ask, or for inquiry or observations and other things, you can contact us using the following numbers. 1. Ibrahim Umar on number 070 36 20 28 42. I'll take the number again. Ibrahim Umar on 070 36 20 28 42. Or you can consult Mr. Williams Ishaku on 081 606 709 20. Mr. Williams Ishaku again, 081 606 709 20. Or of course, you can contact Mr. Philip Mamman on 080 26 59 8861. That is Mr. Philip Mamman, 080 26 59 8861. My students, continue reading your books. COVID-19 is real. So stay safe and practice all the guidelines given by NCDC. Thank you very much. See you in another class.